All right, let's take a look at the questions in 190301A module of the Heavy Equipment Technician program in the Alberta modules. Question number 12. So first, let's start with number 12, and we'll do some separate videos for 12, 13, and 14. So this will be video number 1. So the question says a hydraulic cylinder that has a bore of 10 centimeters. So that means the diameter here across is 10 centimeters. And a stroke of 4.25. That means the full stroke here is 4.25 meters. How much pressure in megapascals is required to overcome a load of 2,500 kgs? So 2,500 kilograms is the load when the cylinder is extending. So we're going that direction. Round off your answers to the nearest 2 decimal places. Okay, so that sounds fine. The first thing we need to do is lay out what formula we're going to be using and then try and figure out which information we actually need. So the formula is going to help us understand what information we need, and the one we're going to use is going to be Pascal's law. That's a really bad triangle, so let's just try again. Slightly better. And let's say we're going to have force, pressure, area. You could use a big A if you want, doesn't matter. So force is equal, the force that's going to be output by a cylinder is going to be equal to the pressure that's hydraulically put in the cylinder multiplied by the area that the pressure will be acting on. Okay, so for us to figure out what kind of pressure is going to be, so that's going to be here, we're not trying to figure out our pressure. What we actually need to do is we need to take our force and we need to divide it by our area. Well, 2,500 kgs is not force. It's actually a mass. What we need to do is multiply it by a constant of 9.8, the acceleration due to gravity, to figure out our force. So in this case, our force is going to be equal to our kilograms times 9.8, or 2,500 times 9.8. That's going to give us a number that we're going to be able to use for our force calculation. Have you done it yet? Me neither. Gives us 24,500 newtons. So newtons is our metric unit for force, and that's what we're going to use. Okay, and so what we get out of this triangle, I think what would have been helpful for us to identify is the pressure will be in pascals for it to be metric, and 1 pascal is equal to 1 Newton per meter squared. Okay, so our force is in newtons, we're good, but our area needs to be in meters squared. So what we're going to need to do is convert the 10 centimeters into meters. And so we need to remember our metric steps. There's another video on the YouTube channel you could find if you need a review of the metric steps. But essentially 10 centimeters is going to be 1/10 of a meter, so 0.10. So you can use pi r squared, or diameter squared times 0.7854 to figure out what your area will be of the cylinder. And so we're going to use 0.1 times 0.1 times 0.7854 to figure out how many meters squared this cylinder is. So let's do that. 0.1 times 0.1 times 0.7854, and we're going to get 0.007854. Some of you that are familiar with decimals and dealing with hundreds and tens, you were like, of course you were, right? Because we had to just move the decimal places. But it's good for us to do it in our calculator as well. So now at this point, we can take our force, which is going to be on the top. We're going to say 24,500. We're going to divide it by our area, which is 0.007854. And remember, that's going to be meters squared and newtons, which is good because that's what our units are going to be. And that's going to come up with our number. So 24,500 divided by 0.007854 is going to give us a very long number, 3119.429.59 pascals. A little bunched up there. Okay, so what we have then is 3,119,429.59 pascals. But the question asked for us to give it in megapascals. So once again, we're going to use our metric steps. We're going to go from pascals to mega. So we're going to go up our 3 places to kilo, 3 more places to mega, and we're going to go 1, 2, 3, 4, 5, 6 decimal places, and we're going to see that it's 3.12 MPa. That is our answer for question number 12. So we're going to see that it is going to take 3.12 MPa, megapascals, to extend this cylinder with a 2,500 kilogram load on it. Oh boy,